Smartphone overuse poses risks to people's physical and mental health. However, current intervention techniques mainly focus on explicitly changing screen content, which is the output, and often fail to persistently reduce smartphone overuse due to being over-restrictive or over-flexible. Strong interventions force users to stop usage, which are often too annoying and disruptive. On the other hand, weak interventions provide subtle reminders but can be easily ignored or dismissed. To design an effective intervention technique with minimal user frustration, we need to investigate the underlying mental factors. The smartphone usage decision-making process can be largely explained by dual-process theory. To engage users, app designers often try to cater to one's desire for immediate gratification and override their logical thinking. Users often just need to use simple tap and swipe interactions. Conversely, research shows that harder or more sophisticated interactions help evoke users' self-awareness. This sheds light on our idea of manipulating input to introduce a mismatch between the issued command and the output on the screen. We present the design and implementation of InteractOut, a suite of implicit input manipulation techniques that leverage interaction proxies to weakly inhibit the natural execution of common user gestures on mobile devices. InteractOut presents a design space of continuous and discrete manipulations on 4 properties, including time, location, direction, and the number of fingers. We further propose 4 intervention strategies, including shift, complicate, extend, and disable. We then demonstrate 8 Android implementations of input interventions throughout our design space, including tap delay, that postpones the time for the user's tap to take effect. Tap prolong, that requires the finger to stay on the screen for a longer period of time in order to single tap. Tap shift, that shifts the tap position away from the actual tap position. Tap double, that requires double tap to trigger a single tap. Swipe delay, that postpones the time for the user's swipe to take effect. Swipe deceleration, that extends the replay time of the user's swipe. Swipe reverse, that reverses the direction of the user's swipe. And swipe multiple fingers, that requires users to use more than one finger to swipe. Along with 5 remaining interventions, our design space affords, such as lock and unlock, and other disabling interventions. We first conducted a pilot lab study with 30 participants to evaluate the usability of the different InteractOut implementations on 2 intensity levels. Participants preferred tap delay, tap shift, swipe delay, and swipe deceleration, which created a higher mental load but a lower physical load. And participants tend to prefer the higher intensity level for most interventions. We then conducted a 5-week within-subjects field experiment with 42 participants to understand how InteractOut influences smartphone usage and user receptivity in real-world scenarios. We compared InteractOut against one of the most common intervention methods, the timed lockout intervention, in which users are locked out of the app when the time limit is reached. Results showed that InteractOut significantly reduced the usage time by an additional 15.6%, and opening frequency by 16.5% on participant-selected target apps. InteractOut also achieved a 25.3% higher user acceptance rate and resulted in less frustration and better user experience. InteractOut was more acceptable than timed lockout because it intervenes with appropriate flexibility, provides user agency, is always on, and introduces a gulf of gratification. InteractOut introduces a new perspective of implicit input interventions that can be compatible with and complementary to existing intervention techniques for reducing smartphone overuse.